Question 5, Part B. A particle moves along a straight line so that its displacement, x meters, from a fixed point O is given by x equals 1 plus 3 cos 2t, where t is measured in seconds. Part 1. What is the initial displacement of the particle? The initial displacement of the particle occurs at time t equals 0. That's the meaning of the word initial in this context. Now, given x of t equals 1 plus 3 times cos of 2t, letting t equal 0, we have x of 0 equals 1 plus 3 times cos of 2 times 0. Now, 2 times 0, of course, is 0. Now, cos of 0 is equal to 1, so x of 0 is equal to 1 plus 3 times 1, which equals 4. Therefore, the initial displacement of the particle is 4 meters to the right of point O. Part 2. Sketch the graph of x as a function of t for t greater than or equal to 0 and less than or equal to pi. The graph of x equals 1 plus 3 cos 2t is the graph of the base curve x equals cos t that has been transformed according to the following. A horizontal dilation by factor 1 over 2. That's because the t is being multiplied by 2, and that results in a compression or a squeezing of the curve horizontally by a factor of 2. Next, we have a vertical dilation by a factor of 3. That's because the cos 2t is being multiplied by 3. That makes the amplitude of cos 2t 3 rather than 1. And because the amplitude now is 3 cos 2t will swing from negative 3 as its minimum to positive 3 as its maximum, rather than from negative 1 to positive 1. Finally, we have a vertical translation upward by 1 unit. So the entire curve, without changing the shape of the curve, is just being moved up by 1 unit. And that's because of this plus 1 that's going on here. So the resulting graph is a cosine curve with period pi rather than 2 pi, amplitude 3, and a line of center 1. Here is a sketch of the curve. X equals 1 plus 3 cos 2t. From t equals 0 to t equals pi. So we have one full cycle of this cosine curve. Now, 3 cos 2t means its amplitude is 3, so it'll swing from negative 3 to positive 3. But because we're adding 1 to negative 3 and positive 3, the minimum now is negative 2 and the maximum is now 4. Notice the line of center, y equals 1, and the amplitude is the distance from the line of center to the maximum or the minimum. So from 1 to 4 is 3, and from 1 to negative 2 is also 3 units. Part 3. Hence or otherwise, find when and where the particle first comes to rest after t equals 0. I'm going to present a graphical approach and then a calculus-based approach to finding the time when the particle first comes to rest and the displacement of the particle at that time. From the graph that we sketched in part 2, the particle is at rest at the peaks, in other words, the maximum values on the curve, and the troughs, which represent the minimum values on the curve. Now, these occur at time t equals 0, t equals pi over 2, and at t equals pi. Now, the question says after time t equals 0, so we can't include this point here. So the first time that the particle is at rest is at time t equals pi over 2. And again, from the graph, the displacement of the particle is negative 2 meters, which we interpret as 2 meters to the left of point O. Using a calculus-based approach, we want to solve dx dt equals 0. Now, x represents the displacement of the particle with respect to time t. So dx dt represents the rate of change of the displacement of the particle with respect to time t. In other words, the velocity of the particle. So what we're solving here is velocity equals 0. Now, the displacement x is given by the formula x equals 1 plus 3 cos 2t. Using the chain rule to differentiate x with respect to t, because we have a composite function here, we get dx dt is equal to negative 6 sine 2t. And we get that by differentiating the outer function, which is the cos function, and we get negative sine, and then multiply that by the derivative of the inner function, so the derivative of 2t, which is 2, and that's where we get the -6 from. Next, we want to solve -6 sine 2t equals 0. Dividing both sides of the equation by -6, we get sine 2t equals 0. Taking the inverse sign of both sides of the equation to isolate the 2t, we get 2t is equal to pi, 2 pi, and so on, bearing in mind that t has to be greater than 0. In the question, it's stated that we want to find the values of t, or the first value of t, where the velocity is equal to 0. In other words, when the particle comes to rest. We can't include t equals 0, and that's why t has to be positive. And that's why 2t can't equal 0 here. So 2t is equal to pi, 2 pi, and so on. Dividing all terms by 2 to isolate the t, we get t is equal to pi over 2, pi, and so on. So the particle first comes to rest when t is equal to pi over 2. Now at time t equals pi over 2 seconds, the displacement of the particle x is equal to 1 plus 3 cos 2 times pi over 2. Now 2 times pi over 2 is equal to pi. So x is equal to 1 plus 3 cos pi. Now cos pi is equal to -1. So we have x is equal to 1 minus 3, which equals -2. Therefore, the particle first comes to rest 2 meters to the left of point O at time t equals pi over 2 seconds. Part 4. Find a time when the particle reaches its maximum speed. What is this speed? The particle reaches its maximum speed when the acceleration of the particle, dv dt, in other words, the rate of change of the velocity with respect to time, equals 0. And that occurs at the points of inflection on the curve. If we go back to the curve that we sketched in part 2, the points of inflection, and they represent changes of concavity, occur midway between the maximum values and the minimum values. In other words, the points in time halfway between when the maximum values occur and when the minimum values occur. So the maximum value occurs at time t equals 0 and at time t equals pi. The minimum value occurs at time t equals pi over 2. The point in time that is halfway between time t equals 0 and t equals pi over 2 is pi over 4. And also, halfway between t equals pi over 2 and t equals pi is 3 pi over 4. So the maximum speed, regardless of whether it's maximum velocity or minimum velocity, the speed is the absolute value of the velocity anyway. The speed is at a maximum here and here. So at time t equals pi over 4 and at time t equals 3 pi over 4. But let's show that using calculus. Now dx dt, which equals the velocity of the particle, v, and that equals -6 sine 2t, which we found in part 3, differentiating v with respect to t, again using the chain rule, we get dv dt is equal to -12 cos 2t. So we want to solve -12 cos 2t equals 0. Dividing both sides of the equation by -12, we get cos 2t equals 0. Isolating the 2t by taking the inverse cos of 0, we get 2t is equal to pi over 2, 3 pi over 2, and so on. And dividing all terms by 2 to isolate the t, we get t is equal to pi over 4, 3 pi over 4, and so on, as expected. Hence, the particle reaches maximum speed at times t equals pi over 4, 3 pi over 4, and so on seconds. Now, at time t equals pi over 4, that is the particular time that I've chosen to find the speed of the particle, we get v is equal to -6 sine 2 times pi over 4. Now 2 times pi over 4 is pi over 2, and sine of pi over 2 is 1. -6 times 1 is equal to -6, so the velocity of the particle is equal to -6. But the question is asking for the speed of the particle, which is independent of the direction or regardless of the direction of the particle. Now speed is equal to the absolute value of v. Now the absolute value of -6, of course, is +6. So the particle reaches the maximum speed of 6 meters per second at times t equals pi over 4, 3 pi over 4 seconds, and so on.